Hey everyone! So in this video, we're going to be continuing to talk about solving trigonometric equations. However, unlike in yesterday's video, today we're going to be doing examples where you actually do need to use a calculator. So in yesterday's video, we were solving things like sine of x is equal to 1/2, or tangent of x is equal to -1. Equations that you should be able to find an answer to just by kind of looking at the unit circle and being familiar with what the different angles are, the different kind of nice angles on the unit circle. So today instead we're going to be solving things that look more like this. So first example we're going to be looking at is we're going to solve sine of x is equal to 0.3. So 0.3 is not one of the familiar x or y coordinates on the unit circle, right? Like it's not 1/2, it's not square root of 3/2, it's kind of a different number. And so when you see something like that, that's what tells you that you're going to have to use inverse trigonometry and a calculator. So we'll get to exactly how that part goes in a minute. So I want to kind of write out some steps like we did in the last video. So the first step in general that you're going to want to do, and we actually don't need to do this here, but I just want to say it anyway. So if needed, you want to start by isolating sine of x. So I'll say if necessary. Here it's not necessary. And I guess I should say that in today's video, we're going to actually be focusing on just solving ones of the form sine of x is equal to something. And the reason for that is that because inverse sine and inverse cosine work a little bit differently, I just wanted to start by doing just inverse sine, see how that goes. And then in tomorrow's video, we'll do solving equations involving cosine, and then we'll also do tangent in tomorrow's video. So first step is isolate sine of x if necessary. We don't have to do that. So second step, this is a step that I think a lot of you are going to be lazy about, or I shouldn't say that. I'm not trying to say I think you all are lazy, but I think in my experience, students a lot of the time are hesitant to draw pictures. I think a lot of people just want to know, how can I get to the answer? How can I skip the part where I draw the picture and just tell me the formula? And I really, really think that when you're solving these types of equations, if you have a picture to look at, I think you're going to be a lot more likely to get the correct answer. So the first thing we're going to do before we actually go in and use a calculator or anything like that is we're going to sketch a rough picture. It's not going to be perfect, of what would angles look like if sine of the angles were 0.3. So we're going to roughly sketch all non-coterminal solutions. So kind of like what we did yesterday, right? The way in yesterday's video, how did we find our solutions? Well, we kind of drew a picture on the unit circle and said, okay, I know what angle that is. And so we're going to be doing something kind of like that, except for here we just have to kind of guess. So what do I mean by that? Well, what does it look like to have an angle where sine of x is equal to 0.3? That means that the y coordinate is 0.3. Right? That's like the definition of sine, is that you go to your angle and you look at the y coordinate on the unit circle, and that is the value of sine. So if we're looking for an angle where sine is equal to 0.3, that means that the y coordinate should be 0.3. So you don't need to be perfect about this, but you can kind of estimate where that would be, right? Because we know that on the unit circle, this point is at a height of 1, right? That's the point 0, 1. And then this would be a height of 0. And so where would 0.3 be? Well, it'll be somewhere kind of at like a third of the way up, so maybe like there. So if we go over to a point on the unit circle that's approximately at that height, then that's a fine enough estimate. It really doesn't need to be perfect. It's just kind of a reference to look at. So this is going to be our first angle, and I'm going to call this x1, right? Because we're solving an equation for x, right? Our solutions are going to be x, and because there's going to be two different non-coterminal solutions, we'll call one of them x1 and one of them x2, just to kind of distinguish between them. So when we're looking for another angle that also has that same y coordinate, where do we look? Well, over here, right? If we go to the other part of the unit, or the other half, so quadrant 2, and we go to a point that has the same height, so the same y-coordinate of 0.3, then we can call this angle x2. So maybe let me kind of summarize what we just did here so that it's clear. So we looked for, we sketched, in this case, sorry, sketch angles whose y-coordinates, or I guess whose terminal points have a y-coordinate of 0.3. Okay, so now we have a picture. We don't know the actual values of these angles yet, but at least we have something to refer to as we move on to the next couple of steps. So the next step is we're going to actually now use a calculator. So how can we find an example of an angle such that sine of that angle is 0.3? Well, we can do inverse sine. So we're going to use a calculator to evaluate inverse sine of 0.3. So we'll do that in a second. And then after we do that, we also need to figure out which of those two angles it is, because it's going to be one of the angles that we drew on the unit circle, and we want to be able to identify which angle it is. So identify which angle from your drawing inverse sine of 0.3 is equal to. Okay, so if we type into our calculator inverse sine of 0.3 and making sure that your calculator is in radians mode, you should get that it's approximately equal to, and I'm going to round to 3 decimal places because I believe that's what it asked for on the homework, 0.304 radians. Okay, so how can we figure out which of the two angles that is on the unit circle? Well, if you remember what types of angles inverse sine gives us, we know that inverse sine will only give you angles between negative pi over 2 and positive pi over 2. So it's impossible that this angle would come out of typing inverse sine into your calculator. It's just never going to give you that angle. It's only going to give you an angle that is in quadrant 4 or quadrant 1, and specifically between negative pi over 2 and positive pi over 2. So based on that fact, we know that that the angle that we just found, that is equal to x1. So remember, x1 was our smaller angle, the first angle that we identified on the unit circle. So that's one of our solutions. We now know that one of our solutions is that x, our angle, could be equal to approximately 0.304 radians. So how do we find the other angle? Well, we can basically make use of our picture and then make use of the answer that we just found and just kind of do some simple geometry and arithmetic to figure out what that other angle is. So we're going to use the drawing and your answer to the second part to find the other angle. Okay, so let's look at this picture. So we just figured out that this first angle here, x1, is equal to approximately 0.304 radians. So how can we find, we're trying to find this angle in green, right? So one thing I just want to point out is that this angle here, if you were measuring, instead of measuring kind of the way that we're supposed to measure angles, if you just kind of went in and just measured that little piece right there, that would have the same angle as what we just found, right? That would also be 0.304 radians because it's symmetric, right? Just looking at the picture, and that's why the picture is so important in understanding. Because these points are at the same height, this angle that I just highlighted in yellow is the same as this angle that we found earlier. And so how can we find the second angle x2? Well, we can do pi, so that would be 180, minus 3.04. So where am I getting that from? Well, pi would be 180, right? That would be that full angle in orange. What is 3.04? Well, we know that it's this angle over here, but it's also this angle over here. And so if we do the orange angle minus the yellow angle, so orange angle minus the yellow angle, we're left with the green angle, which is what we're trying to find. And so our second angle will be x2 is going to be approximately equal to pi minus 3.04 radians. And you don't have to write radians. So why am I writing radians here, and why do we not normally write it? Well, because when you write down a number that doesn't have pi in it, it doesn't necessarily jump out to you that, oh, we're talking about radians. So that's why sometimes when you're writing an angle that doesn't have pi in it, sometimes you might write the word radians, but it's not required. Oops, and I wrote the wrong thing here. This should be 0.304. In general, if there's no unit stated when you're dealing with angles, you should always just assume it's radians. So if you type this into a calculator, you should get, sorry, I had it queued up here. So it's 2.838 radians. Okay, so we found two non-coterminal angles that are solutions, right? So thinking back to what we did in yesterday's video, we're now kind of at that point that we would be at in the examples in yesterday's video, where we start by finding these two non-coterminal solutions. So we have x is equal to 0.304 radians, and then we have x is equal to 2.838 radians. So how do we find now all solutions? Well, now we need to add 2 pi k to each of them to give us, to kind of include all of those coterminal angles. So to describe all solutions, we're going to add 2 pi k to each non-coterminal. I don't know if that's off the page or not. Solution found. So that we have two non-coterminal ones, but then we know that we can also have any other angle that you get to by adding copies of 2 pi. So our solutions will be, and I'm just going to say x, you could say x1 and x2 if you wanted to. I was just writing that out to kind of give some distinction on the picture. But here we can just say x is equal to 0.304 plus 2 pi k. And then the other solution we found is x is equal to, or I should have said approximately equal to 2.838 plus 2 pi k. And let me change this one to approximately. So in some ways, it's very similar to the process from yesterday. It's really just this new thing of using a calculator and then just being able to interpret in your drawing, what am I finding on the calculator and how can I find the other angle? Okay, so let's do another example. And then, yeah, so this next one's going to be pretty similar. And then we'll see one that brings in something a little bit different, and yeah, another one that also brings in something a little different. So first one we're going to do is 4 times sine of x is equal, or sorry, minus 3 is equal to 0. So in this case, we do want to start by isolating the sine of x part. So we're going to start by adding 3 to both sides. So we get 4 times sine of x is equal to 3. And then we get sine of x is equal to 3 over 4. So first step, before we go and type anything into a calculator, let's sketch on the unit circle what those two angles are going to look like. So 3/4. So we're looking for points on the unit circle where the y coordinate is 3/4. So that's going to be a higher up angle, maybe something more like this. So we can call this angle x1. And then the other angle that we're looking for is going to be just like directly across from that, oops, at the same height. And so this angle we can call x2. Oh my gosh, keep erasing my own stuff. Okay, so just like we did on the last one, the next thing that we're going to do is we're going to use inverse sine to find one of those angles. And just actually, even before we do that, we can already tell which angle it's going to give us, right? It's going to give us the blue one because the blue angle is the only of the two angles that's in the right part of the unit circle for inverse sine. There's no way inverse sine is ever going to give you an angle that is in quadrant 2. So we can find our first solution by doing inverse sine of 3/4. So you can go ahead and type that into a calculator, which is what I'm doing right now. And you get that it's approximately equal to 0.848 radians. So that's our first solution. And then what's our second solution? Well, again, it's the same. It's going to come out very similar to the last one because, again, this angle here in yellow is equal to the same measurement as x1, right? So that is also 0.848 radians. And if we did this full angle, that would be pi radians. And so if we do the orange minus the yellow, we're left with the green. So we want to do pi minus, and I guess I should say approximately because we already rounded something. So pi minus 0.848. And that gives us 2.294 radians. And so then to write down our final answer, we just add plus 2 pi k to each of them. So our solutions are, and again, it doesn't really matter if you want to say x1 and x2 or just write x. I just am doing it to be kind of consistent with what we did last time. So one solution is 848 radians plus 2 pi k. And then the other solution was 2.294 radians plus 2 pi k. And by the way, there's one thing I asked you to do. We didn't do it in yesterday's video, but I asked you to do it on yesterday's worksheet, which was find a specific example of an angle other than these two that we just found that is also a solution. So I just want to briefly mention how you would go about doing that. So how would you go about finding another solution? Because what I really want to make sure you understand is when you write this down, this plus 2 pi k business, that means that any multiple of 2 pi added to one of these two numbers is also a solution. So really, when you write this down, you're describing infinitely many solutions. There's not two solutions, there's infinitely many. There's only two that are between 0 and 2 pi, but if you kind of open up to just saying, show me all the solutions, then this 2 pi k plus, I can't speak today, this plus 2 pi k is meant to suggest that it's any additional rotations around the unit circle. So how could you find an example of another solution? So example of a solution that's not in the interval from 0 to 2 pi. Well, for example, you could take your first one, the blue one, so 0.848, and then you could add, let's say, 12 pi. So if you type that into a calculator, that gives you, sorry, 1 second, 848 plus 12 pi, oops, Sorry, I'm having some technical difficulties. So that would give you 38.547 radians. So that's another solution. So I just wanted to really show you, and I think it's, that's something that I might ask you in the future on like a quiz or a test. I want you to be prepared to not just kind of go through the motions of this procedure, but also understand how to come up with other solutions other than the two that you kind of wrote down initially. Okay, so the next example we're going to do is going to be a little bit trickier, or it's going to kind of bring in something different that you're going to need to know for the online homework. Okay, so the next one we're going to do is we're going to solve 4 times sine of x plus 1 is equal to 0. And so the first part of this, of solving this, is actually going to be very similar to what we did in the last ones, but there's something else I'll bring up at the end that basically relates to how on the online homework, they're not asking for all solutions, they're asking for solutions between 0 and 2 pi. Okay, so first step, like we did on the last one, is to start by isolating sine of x. So that gives us 4 times sine of x is equal to -1. So we get sine of x is equal to -1/4. So what's different about this one? Well, now we have a negative sign value, and so that means we're going to be in a different part of the unit circle. So what are our two solutions going to look like? Well, one of them will be at a y-coordinate of -1/4 over here. So that could be maybe what that first angle looks like. And then another angle that would work would be over here. So I'm not going to draw the arrows on this just yet because I want to first do inverse sine because I want to make sure we're thinking about these angles the right way. So how do we find one solution? Well, we can start by doing inverse sine of -1/4. And I'm using the blue because, I know because of the part of the unit circle that inverse sine focuses on, I know that it's going to give me the blue angle. So if I do inverse sine of 1/4, that is equal to approximately 0.253. So this is going to be our first angle, x1 is equal to inverse sine of -1/4, which is approximately equal to 0.253. And sorry, I forgot a negative sign. So it should be -0.253, my bad. I was like, that's not right. Okay, so why did I not draw like arrows on this diagram to start with? It's because I want to make sure that when we're using inverse sine, remember that it gives you an angle that is specifically between -pi/2 and +pi/2. So it would not be correct to say, okay, this angle is equal to -0.253, right? That wouldn't make sense. So it's really this angle that we just found that is x1. It's if you measure in that direction. So that's one of our solutions. How do we find the other solution? Well, in this case, basically the same thing that we have been using all along is going to work, but it's kind of for a slightly different reason. So let's say we wanted to measure this way to find x2. And it would be fine, by the way, if you instead wanted to measure this as a negative angle, you could do that, but I think it's actually just going to be easier to do to go this way. So if we were to go from here to here, that would be pi, right? And then we're going an extra little bit, and that little bit extra that we're doing is actually the same amount as x1, except for it's positive. So how can we find this, the angle in green? Well, we can again actually just do, I always forget to do the approximate thing. We can again just do pi minus our angle. And so why does minus still work? Well, it's because if you subtract a negative, you get a plus. So it's basically like we're taking 180 or pi, which is what I drew in orange, and we're just adding on that little extra bit, which is the negative of the angle we already found. It's basically kind of like a double negative thing. So we're subtracting a negative angle, which is the same as adding. And so if we do that, you get, so pi plus 0.253, we get approximately equal to 3.395 radians. So that is our second angle. So if the question was asked to just find all solutions, then your answer could be like this. You could say x is equal to, or is approximately equal to, negative 0.253 plus 2 pi k. And then you could say x is approximately equal to 3.395 plus 2 pi k. That is a correct answer. That there's nothing wrong with this answer. This describes all solutions. So this would be a correct answer if you were asked to find all solutions. So that's probably, honestly, I might on a test or quiz ask you to find all solutions. But on the online homework, the way that it's set up, you have to find not all solutions, but specifically the solutions between 0 and 2 pi. And that's actually going to be kind of different in this case, because one of the two solutions we found, this one, is not between 0 and 2 pi. I know it looks like it is, but because it's a negative angle, it's technically not between 0 and 2 pi. So I just want to kind of do that as like an extra piece to this question, just to help you with if you encounter something like this on the online homework. So if you were asked instead to find all solutions from that are like between 0 and 2 pi, well, we have one, right? The one that we found in green, that one is between 0 and 2 pi. So we can definitely say as a solution, approximately 3.395 radians. That works. And you can always just maybe do like a quick check for yourself, right? Like 2 pi would be about 6.28. So this number is definitely less than 2 pi. So we're good. So the other angle we found, though, like I just said, is not between 0 and 2 pi because it's a negative angle. So what do we have to do? We have to figure out how to rewrite that blue angle instead of measuring it the negative way, measuring it the positive way. So we basically need to figure out if we were to instead measure like this, what would that angle be? So basically, if you think about it, if you do 2 pi, so 2 pi would be going all the way around like this, right? Like full circle. And then if you add on x1, so remember x1 is a negative angle. So when I say add x1, you're actually subtracting it. So if you take 2 pi and then you subtract out this little extra bit, which you really do by adding it because it's a negative angle, that will give you an angle between 0 and 2 pi. So the way we can write that is just say, x is approximately equal to 2 pi minus 0.253, right? So the minus 0.253, that's coming from adding that negative angle that we found earlier. So what are we going to do here? We're doing 2 pi minus 0.253. Oops. Sorry, y'all. I'm having a lot of calculator issues right now. I'm just not typing very well. 2 pi minus 0.253. So that gives us approximately equal to 6.030. So that would be the angle that actually is between 0 and 2 pi. So if the question was asking us to find solutions between 0 and 2 pi, we would need to actually give these two solutions and not the two that we found originally. And I think, again, like I said earlier, there's a tendency for students to want to kind of memorize, oh, what do I have to subtract from what? I really, really think you're best off if you just draw a picture and just think about adding and subtracting. Think about geometry. Think about, how do I get this? What do I need to add to this? Or what do I need to take away from this? Just kind of using your picture, I think, is really the best way to go so that you don't end up using the wrong method in the wrong place. So to find the green angle, we did, pi minus our original solution, and that was because of, again, how the picture looked, that it helped us to find that green angle. But to then translate the blue angle to being a positive angle, we did 2 pi minus that angle. And so that was because of basically the picture we drew in purple here, that, going all the way around would be 2 pi, and we want to subtract out this little extra bit. And so because it's a negative angle already, we can just add it, and that will have the effect of subtracting out that amount. And I guess maybe one more way to think about it is that, so you can always find coterminal angles by adding copies of 2 pi. So if you think back to earlier in the quarter, we did some questions where I might have said, find an angle between 0 and 2 pi that is coterminal with this angle. And how did you do it? You basically just added or subtracted 2 pi until you got a number that was between 0 and 2 pi. And so in this case, because you can tell that this angle is not between 0 and 2 pi, you can just add 2 pi until you get a number that is. And that's really what we did. We took negative 0.253 and we just added 2 pi to it. And that gave us our final answer, which is between 0 and 2 pi. Okay, I want to do one more example. And this example, I don't want to spoil it, but it's going to be a lot faster than the earlier ones. So let's say we wanted to now solve negative 3 times sine of x minus 5 is equal to 0. So first step, like we did on the last ones, is to isolate sine of x. So we get negative 3 sine of x is equal to 5. Then we divide both sides by 3, so we get sine of x is equal to 5 over negative 3, or negative 5/3. So what's wrong with this equation? Well, this number, negative 5/3, this is a number that is smaller than negative 1. And we know that sine of x is always between negative 1 and 1. So I don't know if I've ever written it down this way, but this is a way of kind of summarizing that idea. So we've seen that no matter what angle you plug into sine of x, you're never going to get something that's bigger than 1 or smaller than negative 1. So that tells us that there's actually no solution to this equation, because it's not possible for any value of x that sine of x is going to be equal to negative 5/3. And if you were to try to type inverse sine of negative 5/3 into your calculator, you would find that it would tell you domain error, or error or something like that. All right, so that's it for today. So like I said, in tomorrow's video, we'll get into solving very similar types of equations, but with cosine and with tangent. And yeah, I will see you all then.